Good morning, ladies and gentlemen. Today is Monday, March 8th, 2021. For class today, you will need your MacBook. Obviously, you're also going to need headphones for this screencast. Just a friendly reminder that your house drawing for the Keeping It Hot project is due tomorrow. Before you start the screencast, please be sure you get the notes about Intro to Earth's Water, and you're going to open or send those to Cami. I think that I have it set up on Canvas so that they're already embedded for you. So far this year, we have explored changes in Earth's land through our study of geology, as well as changes to Earth's air, more specifically, our study of meteorology and weather. But we're going to focus now on the thing that makes Earth unique among all planets. Earth is known as the water planet, and many people refer to it as our blue marble. In fact, 71% of Earth's surface is water. Hydrology is the study of Earth's water systems. We are going to be looking at two of Earth's different water systems. Although closely connected, we separate them out. We are going to look at Earth's oceans, and we are also going to look at Earth's freshwater. So this image is one that always kind of stops me in my tracks. When we think about what kind of water is on Earth, we have three different blobs of water here, if you will, or water drops. So this first and largest represents all of Earth's water. And somewhere between 97 and 98% of that is salt water. Only 2.5% is fresh water. This middle-sized blob represents all of Earth's freshwater found in lakes, swamps, rivers, and underground. All of it. But the smallest, tiny blob that many of you may not have even noticed was there, that is Earth's freshwater that is on its surface, for example, in lakes and rivers. That is the freshwater that we have easy access to. So although we call Earth the water planet, and water is so much a part of our survival, there's not a whole lot of fresh water that is readily and easily available to us on Earth's surface. So shown another way, you have this graph in your notes as well. We have a pie chart, and we can see that 97% of Earth's water is ocean water, whereas only 3% is fresh water. When we look at that 3% of fresh water, we see that 70%, almost 3/4 of it, is trapped in glaciers, most of them being at the North and South Pole. Another almost third of it is underground. Sometimes we have access to that underground water, other times we do not. And we see that less than 1% is in rivers and lakes, which are easily accessible to us on Earth's surface. So salt water is the water that is found in the oceans and some inland seas, for example, the Great Salt Lake in Utah. And the saltiest location of water on the planet is the Dead Sea. And you can see the woman floating in the Dead Sea. Those two things nearby her are not icebergs. Those are salt rafts. So that is all salt. And you can see how very high she is floating in that water. Salinity comes from the Latin root sal, which means salt, and it is the total amount of dissolved salts in a sample of seawater. You can see in the diagram that when we pull out, for example, 1,000 grams, which is a single kilogram of water, about 965 grams or 96.5% of that is going to be salt. excuse me, fresh water, whereas the other 35 is going to be salt. Some of you may be noticing this symbol down underneath where it says salt water, salinity equals 35, and then it has that percent sign with an extra bubble at the bottom. That is parts per thousand. And then in the top graph, we can see that a majority of the dissolved salts in ocean water are going to be chloride and sodium, NaCl. So that is exactly what is on your kitchen table in a salt shaker, NaCl, sodium chloride. So on average, 1 kilogram of ocean water contains about 35 grams of salt, or 35 parts per thousand. We have natural processes that affect salinity. Some of them increase salinity, some of them decrease salinity, but overall, Earth tends to keep the salinity in balance. So, whereas you might have individual locations on Earth that the salinity is slightly higher or slightly lower than that 35 parts per thousand, overall, on average, our ocean water is 35 parts per thousand. We can change salinity. We can either decrease it or increase it. So, to decrease salinity, we are going to add fresh water. And the ways that we can add fresh water are through precipitation, the melting of sea ice or icebergs, as well as runoff from land, especially rivers entering the ocean. The flip of the coin, of course, is processes that increase salinity. And in this case, we are going to be removing fresh water. Those processes include evaporation, as well as the formation or freezing of sea ice. So, because salt water has salt in it, it does not behave exactly the same way that fresh water does. So, one of the things that happens with ocean water is that it does not freeze until the temperature drops to about negative 1.9 degrees Celsius. So, just about negative 2 degrees Celsius is where we see freezing instead of 0 degrees Celsius. That is why in areas of the country that get snow, they salt the roads before an oncoming storm. By putting salt on the roads, the hope, of course, is that they decrease the freezing temperature from 0 degrees Celsius to just about negative 2 degrees Celsius, so that it keeps the roads unfrozen longer. And then, of course, salt water is going to have a higher density than fresh water, which is going to provide a greater level of buoyancy. You will learn all about buoyancy in 8th grade physical science. So, if we were to take a tank of fresh water and salt water, and we had exactly the same amounts of fresh and salt water, if we were to pour them together, we would see that the salt water would settle out to the bottom of the tank, and the fresh water instead would be at the top of the tank because salt water is going to have a greater density. The temperature of ocean water is going to vary with both location and season. This is something that you know inherently. For example, the water temperature in Florida is going to be warmer than the water temperature on Cape Cod. So there's our location. And you also know that the water temperature in Florida is going to be warmer in August, September, and October than it is in January, February, and March. Remember that warm water is less dense than cold water. So warm water will form just a thin layer on the surface. And that has to do again with convection, but also the fact that the sun's light is only able to penetrate so deeply and transfer that heat to the water. And again, you may have experienced this if you were at the beach and you were walking out, and suddenly from your waist down, the water was much, much colder, or it was much colder at your feet than it was at your shoulders. And again, that is just because that colder, denser water is going to settle towards the bottom, and that warmer, less dense water will settle at the top. You should know through common sense that because there are things that live in the ocean, that means that there has to be gas in the ocean water. And we have two gases that are really important for life. First is carbon dioxide, and the second is oxygen. Now, again, these are going to vary in amount and location within the ocean. So, interestingly, carbon dioxide is fairly consistent throughout the water column. That means the amount of carbon dioxide that you find at the top of the water is going to be almost the same as the amount of carbon dioxide that you find at the bottom of the water. However, oxygen is a different story entirely, because oxygen in the ocean water is going to come from the photosynthesis of green plants. Remember, for photosynthesis, we are going to take in carbon dioxide and then turn it into a sugar and release oxygen gas. So, this means that oxygen is going to be concentrated in the topmost layers of the water where those green plants are able to photosynthesize. If photosynthesis isn't able to take place, and think about that as you get deeper and deeper into the ocean, there's less and less light that's able to penetrate, means our oxygen is also going to decrease with depth. So CO2 is fairly consistent throughout the water column, whereas oxygen is going to decrease with depth. It's going to be most highly concentrated where we have green plants that are able to photosynthesize. Freshwater. For our definition, we are just going to say that freshwater is water that isn't salty. Notice we're not saying anything about it being clean or unpolluted or drinkable. We're just simply saying it's not salt water. Where do we find fresh water? Well, we already previewed this at the start of lecture. So about 76% of our fresh water is going to be locked in ice. Majority of that is going to be in the ice caps at both the Arctic and Antarctic. But then we also have things like icebergs and sea ice. So when ice freezes, it leaves behind the salt, but it freezes as fresh water. About 23% of it is going to be found below Earth's surface. Get this, we call water in the ground groundwater. I know, guys, scientists can be so creative. So, groundwater is water that fills in the cracks and spaces underground around soil and rock layers. Um, and you have probably experienced this at the beach. If you have ever dug a deep enough hole that the bottom of your hole starts to fill with water, you have hit that point. You've hit the water table. So, the water table is that point where your unsaturated zone and your saturated zone meet. At the beach, we can do this in just a few feet, but think about how deeply down the water table might be in areas that are very mountainous, like the Rocky Mountains. The other thing is that we often think of groundwater as moving like a river. And in some places, that is true, that water can move very, very quickly. But in a lot of places, that water may not move at all, or may only move a few centimeters every 1,000 or million years. So, although we do have access to some of our groundwater, there are huge portions of our groundwater that are just simply out of the way. We cannot reach them. Lakes and rivers on Earth's surface make about 0.34% of our fresh water. Not a whole lot. And of course, that would be the easiest place for us to gather fresh water from. And then finally, water vapor. makes up 0.037%. So that water vapor in the sky that creates the clouds, yep, it's only 0.037% of our fresh water sources. So, water moves around Earth through the water cycle. I know that you guys have a song that you were taught in 5th grade about the water cycle. You may start singing it now if you wish. Just remember that it is the energy from the sun that drives the water cycle. Energy from the sun. So here is a video, I believe it's about 6 minutes long, from NASA about the water cycle. It does a really nice job explaining things.
Water is the fundamental ingredient for life on Earth. Looking at our Earth from space, with its vast and deep ocean, it appears as though there is an abundance of water for our use. However, only a small portion of Earth's water is accessible for our needs. How much fresh water exists and where it is stored affects us all. Nearly 2/3 of this fresh water is stored in the polar ice caps, snowpacks, and glaciers, making it inaccessible for long periods of time. The water cycle is dynamic. It describes the continuous movement of water on, above, and below the surface of the Earth, and the transitions from one state to another. Sea surface temperature, surface winds, and air temperature influence the rate of evaporation at the ocean surface. In the tropics, warm ocean surface temperatures support high rates of evaporation. Wind also increases evaporation. When the air's temperature is warmer, it can hold more water. While the atmosphere does not store a large quantity of water compared to the ocean, rivers, and lakes, it can transport water quickly from one place to another. Low-lying regions of the atmosphere with high moisture and strong winds can form atmospheric rivers to transport water horizontally. Clouds are formed as water vapor cools and condenses into droplets and ice crystals. Clouds and water vapor act as insulators in the atmosphere. Clouds help shield the Earth from the sun and trap heat from below. When cloud particles grow large enough, they may fall out as rain or snow. Under the right conditions, areas of precipitation can grow into large storms. As storms grow, they transfer heat vertically into the upper atmosphere. The migration of storms helps to distribute heat between the equator and poles, shaping wind patterns globally. How storms grow and intensify depends on atmospheric moisture, surface temperatures, and wind patterns. Precipitation is concentrated in some parts of the world and scarce in others. It can vary substantially from season to season and from year to year. Water that falls on the land surface as precipitation is stored within snowpacks, lakes, reservoirs, soils, and underground aquifers. Water availability varies from place to place and over time. The availability of water affects the type and abundance of vegetation, the primary source of food for animals and people. Extreme water cycle variability, unusually dry or wet conditions, impacts humans worldwide. Each year, hazards such as floods exact a costly economic and human toll. Most of the water that falls onto land remains stored there for weeks or more. Snowfall is stored as snowpack or ice. Meltwater and rainfall are stored in lakes and soils. Some of the water is absorbed by plant roots or drains into the water table. Eventually, the water will evaporate to the atmosphere or return to the ocean in streams and rivers, providing a source of nutrient-rich water that supports ocean life. Sensors on a suite of NASA satellites observe and measure water on land, in the ocean, and in the atmosphere. These measurements are important to understanding the availability and distribution of Earth's water, which is both vital to life and vulnerable to the impacts of climate change and a growing world population.
All right. So, just a very basic refresher on your water cycle. Of course, the energy that drives the water cycle is going to come from the sun. We can pick any place to start here because it's a cycle, so we're going to go back to where we begin. So let's start with precipitation. Remember, precipitation is going to be any form of water falling from the sky: rain, hail, sleet, snow. It is going to collect in Earth's water basins, mostly our oceans, but other things as well, like rivers or potentially underground. Then, as it heats up, it's going to evaporate off the surface where it enters into the atmosphere. And then, at a certain height in our atmosphere, it is going to reach that 0 degrees Celsius mark and condense. And once there is enough water vapor in those clouds, it is going to precipitate, and the whole cycle begins again. So, quick questions for you. When rain falls into the ocean, what kind of water does it become? That's correct, it becomes salt water. What about when water evaporates out of the ocean? What kind of water does it become? Very good, fresh water. So we can see that natural processes keep this fresh and ocean water in balance, where we have about 97.5% salt water and about 2.5% fresh water. So the natural processes help keep everything in balance. But what about people? Are we a natural process? Have we always been here? No. So at this point, is the amount of fresh water that we have limited? You should be giving me a resounding yes. And what does that mean if we have a limited resource? It means that we can eventually run out. So if we are overdrawing or overusing our freshwater resources, we're taking more than is naturally resupplied, we will run out. So we can lose our fresh water. How? Anything we do to remove water from that natural water cycle means that we're losing fresh water. So this video is one of my favorites. The facts are already written into your notes for you. I just want you to watch, and I really want you to kind of keep track of the 2 or 3 facts that pull you up short or that make you say, whoa, The 2 or 3 facts that hit you at a gut level. That means drinkable. All right, so in your notes, I would like for you to highlight or put a star next to the 2 or 3 facts from that video that make you stop and go, whoa. So, World Water Day is a UN celebration that occurs every March 22nd, and the theme changes annually. This year, the theme is valuing water. And the question is, what does water mean to you? And they say that water means different things to different people. This conversation is about what water means to you. How is water important to your home and family life, your livelihood, your cultural practices, your well being, and your local environment? And their hope is that by recognizing the value in water and all of the different ways that we use it, we will stop using water frivolously, and that instead we will value it the same way we do other limited resources like gas and oil and fossil fuels. So, Lake Highlands Upper School has a club. It's called Water for the World, and they are hosting their second annual Walk for Water on Saturday, March 20th from 9 a.m. until 12 p.m. Water for the World has been raising awareness about the water crisis and funds for the Thirst Project. The Thirst Project is a nonprofit organization that works with the support of young people to help end the global water crisis by building freshwater wells in developing communities that need safe, clean drinking water. This year, Water for the World is aiming to raise $10,000 to facilitate the development of one well. The Walk for Water is a crucial aspect for reaching our goal, as the funds raised from the walk will go directly to achieving this mission. So on Saturday, the 20th, there will be a 3.5 mile walk around campus. It will include food, games, raffles, for enjoyment, collaboration, and spreading awareness about the world water crisis. If you are interested in signing up, you have that link. I believe that it has also been included in the upper school weekly notes for the last week or two as well. To support Water for the World on the middle school campus, we will be having a Wear Blue Spirit Day on Monday, March 22nd, which is World Water Day. So you will wear as much blue as you can to help celebrate World Water Day and raise awareness about the freshwater crisis. A minimum of $1 donation will be collected in your science class that day. All of the money is going to go through Water for the World's club goal of $10,000 to help build a well in a community that does not have access to fresh, clean drinking water. So, if you have a little bit of extra time now at the end of class, you have two options. Number one, if you are not done your Keeping It Hot house picture, I would love for you to use this as an opportunity to work on it. Remember that rulers are on the back counter. If you are finished your Keeping It Hot house image, then go ahead and go to worldwaterday.org and you can click on Learn. There's also a fantastic video from Vox, VOX, about the freshwater crisis. It is available through YouTube, and I think it's about 18 minutes if you had any interest in learning more. That is the end of lecture for today. Again, please use this time either to work on your Keeping It Hot house part of your project or to explore more about the world water crisis. Hopefully, I will see you guys tomorrow. Bye.